course, is an organization. We are an independent association there. We have around about 100 companies as our members, and we are a privately funded association. And what is the main focus for, of course, is actually we are promoting open source systems and solutions for the market. As you know, that the biggest problem actually for the open source always has been that you are fighting against very global marketing machines like Microsoft, etc. And for the open source, such a marketing machine doesn't exist. So our companies, membership companies, has created one, and we are that kind of a organization that we are doing the marketing for the open source in general. Okay, this year then we are working there in Finland and also on the European level, trying to influence different kind of decision makers, and that's why we have, in the row of the years, we have networking pretty well on certain levels, and FSFE Finland Chamber was asked to organize a little bit program here, and Otto Kekäläinen, actually, who's sitting here and is running the FSFE Finnish Chamber, asked me to take the lead on this, and that's why we decided that okay, that COS can contribute to the FSCOS this year and organize this technological track. And of course, as you know, that Edward Snowden and whole PRISM situation has been very, let's say, descriptive for this year, that all the talks they have been about the Snowden and all the incidents about there. And that's why we created the name for this track, which is Trust is Good, Control is Better, which means pretty much that with all these techniques what we are showing and showcasing today, the users can actually control how the data what they are having is owned. We are starting today with Henri Bergius' presentation about the NoFlo, and the reason for this is that I'm very, very thrilled about this flow-based programming what Henri is creating. Also, it's a Kickstarter project. Henri managed to get what it was, almost $120,000 through Kickstarter, and they are now up and running with the project, but let Henri go in details. But anyhow, I really believe that, let's say, in the future, if we are getting this kind of a tools what Henri is creating, that is helping the everyman to understand better what the programming is all about and how that should be controlled, and that's why it's fundamental that we understand how the programs are written. All right, Henri, stage is yours, and let's go and dig into the NoFlo.
All right. So yeah, good morning everybody. I'm Henri Bergius. I've been in the free software circles for quite a while. I'm originally from Finland, but now living in Berlin, where things are different. But anyway, to flow-based programming. So first let's talk a little bit about like how to manage concurrency and the control flow of your software in traditional programming languages. So I mean, if you've done, let's say, Java or PHP, this is probably the pattern you've seen, where things are synchronous, and you usually work with this call return concept, where basically you call a function, it does something, let's say reads a file, makes a database query, talks to a web service, and while it's doing that, basically your whole software flow is on hold. Nothing happens until it actually returns a value. And this is kind of problematic because in the real world there are a bunch of things happening at the same time. And similarly with a lot of software nowadays, we are not in the Windows desktop world anymore, where you had only one user, you had no internet connection, and that user was the only person doing anything. So basically you only had one screen to output to, and you had a mouse and a keyboard to listen to. But now we build a lot of network services where we actually have to support multiple users doing things at the same time. And there, this concept is a problem because generally your software doesn't proceed while it's doing something. So to solve this, for instance, how many of you have done anything with, let's say, Node.js? One. All right. So the typical concept from functional programming is continuation passing style, where instead of your control flow being blocked and stopped while the function is doing something, you actually just call the function and then you give it another function to say, okay, when you're done, call this function. And this is the way your software flows. In which situation, actually whatever happens here can happen while this thing is happening, which allows you to do multiple things at the same time. Let's say, if you're doing a web service, you might actually have 2 people requesting a web page at the same time. Shocking, I know. But the problem with continuation passing style, how many of you have done JavaScript? jQuery? Yeah. So this is what everybody's first Ajax call in JavaScript looks like. You end up building these Christmas trees where you give a function, you give a function, you give a function, you give a function, and so forth. And, it's nothing to be ashamed about it. My first asynchronous JavaScript looked like this too. But if you're building anything more complicated, it becomes very difficult to manage very quickly. And when you're dealing with the large code base, instead of that Christmas tree, it would be nice to see how the data flows through the system, what things are connected. It would be nice to have a map to what's happening, right? I was thinking about these things for quite a while. I was kind of changing programming languages and changing a little bit what I do for work, and I was really thinking, I was really frustrated at the state of programming. I thought, dealing with things like this is it's just too complicated. We end up writing and rewriting everything all the time, and we have no big picture of what's going on. So I was giving talks in a couple of conferences in the US, and I decided to take a little road trip on the Californian coast to clear my head and, of course, to get from one conference to the other. And while looking at scenery like this and driving among these big redwoods, I had some time to think and to read some papers in the evenings and all that. And this is where I ran into the concept of flow-based programming. Flow-based programming is not a new concept. This gentleman over here, Paul Morrison, invented flow-based programming at IBM in 1968. So we're talking about bleeding edge technology here. And when he retired from IBM, he wrote a book. And I ran into a couple of papers about it. I bought the book, read it, and I thought, this concept actually makes sense. And eventually I got in touch with Paul and talked about how we could bring his ideas from the punch card era or the Java era to the modern web stack. He's been very, very helpful in the whole process of NoFlo because he's been guiding us all the time. So what's the idea of flow-based programming? The idea of flow-based programming is black boxes called components. You can think of a component as a function, or like Alan Kay here, one of the fathers of object-oriented programming, he was thinking about these biological cells. The idea here is that you have a unit of software, a black box that provides input ports and output ports. Whatever happens inside the box, you don't have to care about. You just provide inputs, and eventually it might provide outputs. And this is all that software essentially is. That's what a function is, right? The difference about flow-based programming and traditional programming is that flow-based programming is about how you connect these different black boxes together. It might sound familiar. I mean, how many of you are, let's say, Linux users? That wasn't very surprising. So the Unix philosophy, yeah, I mean, you write a thing, write the program, and it does that one thing. It takes inputs and it produces outputs, and you can connect these together. I mean, the good thing there is, first of all, you can connect anything to anything, basically. And secondly, the second good thing is, if you focus on creating these little blocks of software, these components that just do one thing, generally you can write them once and then just reuse infinitely. I mean, I have no idea, like, when was, let's say, the source code of cat or ls modified last time? Any good guesses? I have no idea.
Yeah.
Probably in the 80s. I mean, this is a flow-based program. You run one command, you provided some inputs, you take the outputs of it, you send those to another command, and so forth and so forth. Basically, Unix pipes are a flow-based programming environment. It's a flow-based programming environment that most of you have probably used, at least for killing a browser that's hanging or something similar. But the thing about Unix pipes is that it doesn't really make it easy to split things apart, or especially to merge them later together. And so what we are saying is that Unix pipes are essentially flow-based programming in one dimension. And what we're trying to do with NoFlo is to give it the second dimension. So basically, each of these is a component, a reusable, or instance of a component, a reusable piece of software. You can see what input ports it has, and you can see what output ports it has. And then each of these blocks, they don't know anything about their surroundings. They only see what input they get, and they can send output. They don't really know who, like this guy here doesn't know who it's talking to. So the logic of the software is actually in the graph, in the way that these blocks, these reusable boxes, are connected together. Again, not a terribly new idea. This is a screenshot from a presentation given somewhere in 1960s about the graphical input language, where in, I think, Rand Corporation, one of the American defense companies, they built a visual programming environment that you could control with a pen. You could draw a box, it would become a component. You could draw a line and it would connect two boxes. You could scratch things out. Things that kind of are now coming to touchscreen devices. But obviously it had various shortcomings, like you actually had to use handwriting recognition to write the names of the components. And you can imagine how handwriting recognition worked in the 60s. So it was quite clunky. 80s, how many of you have used LabVIEW? Nobody. LabVIEW is kind of a simulation environment. Still used a lot for teaching engineering, for instance. People either love it or hate it. Pure data came in the 90s. This is more for audiovisual things. A lot of media artists use pure data for creating different things. I've seen really amazing pieces of software, but as you can see, pure data can look a little confusing. And then Paul Morrison, when he retired, he wrote a Java program called DrawFBP, where you can define these flow-based programs. This is actually a NoFlo program done in DrawFBP, where we read a file. The file reader gets a file name as an input. We split the string by new lines, and then we count the number of lines we get. So this piece of visual software here basically is a very fancy way of counting how many lines of something you have in a file. Everybody understands it. Stuff flows in, stuff flows out. Each box does something about it. But, and then, yeah, recently these ideas have kind of been revived. There's a project called Mimo, done by Forest Elephant in Helsinki. And that's more tuned towards teaching programming, kind of giving a tool for people to build visual toys in a visual way. And Mimo is interesting in the sense that Forrest, who built this environment, actually decided to join forces with us, and he's now working on the NoFlo environment with me. But, I mean, when I'm talking about NoFlo, this is what most people ask. It's like, we've had these different approaches at visual programming. There's always been these promises that eventually, you know, you don't have to learn these clunky, esoteric programming languages. You can just draw things. Some people even go as far as say, you know, you can fire all your programmers and the managers can build their software themselves. But none of this has ever happened. I mean, we've had these things. Some of these visual programming environments have found an audience, like Hollywood, all the special effects in films, the behavior of the characters in these big battles in Lord of the Rings, that was all done in a visual programming environment. But for general purpose programming, nobody does websites in a visual manner. Nobody does Android apps or Windows apps in a visual manner. So even though people have been trying these visual programming things for 40, 50 years, it hasn't really caught on. So what's different now? I mean, why do I think this time it might actually work out? One big thing is our device landscape has changed. I mean, we had these machines, these big boxes here with various input devices. And that's not really, like, these devices are glorified typewriters, right? They are very good for dealing with text, but visual manipulation of things is not so nice. Whereas now you have all these touchscreen devices. I'm sure most of you will have a touchscreen device in your pocket. And with touchscreens and with things that can take pen input, you can actually build a much nicer user experience for modifying these visual graphs than you could on the traditional computer. And the other thing, of course, is that an iPad or an Android tablet or whatever is great for visual manipulation, but it's not very good for dealing with text input. So people have been trying to figure out, okay, you know, I have this fancy tablet that I like to use. It's always connected to the internet. It has a full day battery life, but I can't really do anything with it. So one thing there is also, we think, with flow-based programming, we can actually make these devices something more than entertainment. We can actually make them productive tools. But that's only one thing that has changed. The other big part of why I think the time for flow-based programming might have come is that software development itself has changed. I mean, now we're dealing with multiple protocols, multiple devices. We have to provide our software not only for the desktop, but also for various different mobile form factors. We might want to be able to talk to a smartwatch or Google Glass or something in the future. We might be dealing with different physical devices. So we have a lot of different streams of data. And then at the same time, on the other side of our software, we are usually talking to a lot of different web services to do authentication, to fetch data, to store data, all of these things. And this increases the complexity of creating software, because you can't think that the user is alone in the universe. You have to always think of multiple users, multiple devices, a lot of things happening at the same time. And that means when you're dealing with streams of data, it's kind of nice to be able to see where the data goes and where it comes from, right? And that's the other reason why I think something like flow-based programming would probably work this time. And yeah, as Ilkka mentioned, we tried this interesting thing. NoFlo is free software. Everything around it is free software. But, you know, even in Berlin, beer isn't free. So we have to fund our living somehow. And for that, we put NoFlo to Kickstarter. How many of you did contribute to this? 1, 2, awesome, thank you very much. And I mean, a lot of people were kind of naysayers. They said, you know, that's not gonna work. Nobody's gonna give money to a obscure software development environment. But actually, at the time, this was the 5th largest software Kickstarter. So that shows we actually had pretty good support from people. And I'm really happy about that, because now we have the resources to change how software is built. I mean, if you want to see more propaganda about NoFlo, go there and watch the video.
And you heard about this, that since I'm not very familiar about how the Kickstarter as a process, how that works, can you describe a little bit, since I think this is I don't know if you guys are, but I'm pretty interested that how did you get into the Kickstarter network and how all that happened?
Okay, so to get your project into Kickstarter, yeah, you basically log in, you create an account there. You have to have an American or UK based, or I think Australian company, to be able to receive money on Kickstarter. You create a project there, you write the description, you upload your video, your photos, and then you create a set of rewards. What will people get if they give you money?
Okay.
And then, when you're done with all of this, you send it to Kickstarter for a review.
Okay.
And then you wait a couple of days, they will give you a thumbs up or down, and once they give you a thumbs up, then you get a launch button.
Okay.
And then you spend about 15 minutes with your mouse cursor hovering over the launch button. Should I really want to do this?
Should I?
And I mean, we were talking with the Ouya console team, and Kickstarter is basically a way to convert publicity into money. So getting the project into Kickstarter, having an awesome video, all that's one thing, but really what you need to do is PR. And that was cool. I mean, we had NoFlo and flow-based programming covered in a lot of the programming websites, but also things like Business Week. So,
was there any kind of obligation that you signed it up with Kickstarter itself? I mean, when you went in, did you get any obligations from Kickstarter that you have to do something for the Kickstarter? Or?
No. It's just basically, I mean, they take a cut of the money.
Okay.
They handle the payments.
Right.
That's it.
Right.
It's a pretty high average contribution. I mean, 1,000 and 100,000.
Yeah, because we had these company packages there, so actually a lot of companies contributed. So that was nice. I mean, flow-based programming is kind of a professional tool, so it was obvious that companies are kind of interested.
So in short, you would say that even coming from Europe, the Kickstarter was easy. Even coming from Europe, the Kickstarter was easy process.
Yeah, it was reasonably easy process. Yeah. So how does NoFlo actually look like? This is our current user interface prototype that we are working on, next to the support from all of you. And here I'm showing a very simple visual example of flow-based programming. We have a clock. So I can start the clock running. Yep. And you can sort of see what's going on here. So here we run an animation, and each tick of the animation creates a date. So we take a timestamp at every tick of the browser's animation clock, and we send that around. So here we calculate the time zone, and then we calculate how we should turn the hour hand. Here we here we turn the minute hand and the second hand. And the beauty of flow-based programming is that you can actually see what's going on there. So you can touch any of these wires and you can see the data passing through that wire. So here we have a running piece of software and we can go and introspect it in real time. And not only that, but we can actually make modifications to it. So we could, for instance, if we want the minute hand to move differently, we could go and modify the parameters it gets. And now you can see it's obviously wrong, but
can't you just open the source code and modify it directly here?
this is the source code. The graph is the source code of the clock.
Okay, I just imagine that maybe you have somewhere in some kind of Java code as we expect.
Each of these boxes is implemented as a component. Each of these boxes is a piece of JavaScript. But none of the boxes know about the thing we're building here. That's all in the wiring. That's all in the graph.
So can you open the black box while
Not yet. I can show you later how the components look like. That's something we are actually adding into the tool. And of course, you know, you can modify the software while it's running. You could add new boxes. You could change how the data is routed. And in this case, what I'm showing is basically a very simplistic web application. Here, the NoFlo user interface, the thing here, is actually talking to a separate web page here, which is the running web application. But NoFlo, the user interface, actually has a network protocol it uses to talk to a flow-based programming runtime. And with the same user interface, we can control things running on the client, but we can also control things running on a Node.js server process. And I've seen people do things like control things in the GNOME shell, which is also another JavaScript environment that NoFlo can fuck with. And very interesting one done in Norway is a project called MicroFlow, where Jon Nordby took the concept of NoFlo and he re-implemented that for Arduino programming. And he connected that using the network protocol with this user interface. So he was able to create the control logic for his fridge this way. You just had a little bit different boxes, you know, you are not rotating something, instead you are reading the temperature data or sending commands to the cooler, you know, increase the, like, make it colder, make it warmer, all of these things. So you can really control real world things with this.
The colors on the connections, do they have some semantics or is it just as a comment?
That's just a comment, yeah. I mean,
It's not the type or something in the...
by default, the color of the connection comes from the type, but then you can go and you can change them. So I often use kind of semantic colors. Like here we have purple for the hour, green for the minute, and red for the seconds. So it's just kind of, it helps to increase the visual clarity of the software. And yeah, I mean, this is the, and of course I can stop NoFlo too. This is the kind of current iteration of the software. We are actually improving the graph editor because there's a couple of problems with this one. One of them is these boxes are quite big. And so it's a little hard, like if you have more complex, bigger graphs, you really have to do a lot of zooming in and out to keep track of what's going on. So, and the other one is, at the same time, while the boxes are big, a lot of things in the UI, like the little handles that you can use for manipulating the connections, those are actually quite small, which means this is not very nice to use on a touchscreen. So this is something, even if you're following NoFlo, you probably haven't seen. This is the same graph done in our new UI version. And here you can see a couple of things. This is still a very early prototype, but you can see a couple of things. One is that we really compressed how things are shown. So you can fit a lot more of the graph on the screen. And the other one is we now have these gestures that you can use for, let's say, connecting things. So to swipe left or right, you kind of zoom into that node, and then you can connect it with another one. And the nice thing with this is that these gestures work very nicely with your fingers too, because we have big touch targets and clear motional directions and all those things. And also to help keeping track of the graph, we looked at Civilization 1, a wonderful computer game that I wasted way too much time on when I was a kid. And we implemented the minimap from there. So when you scroll around or zoom around, the minimap will tell you which part of the graph you're actually seeing. And we did a couple of other gestures from the 60s Grails demo. Now, I've never tried this on a mouse before, so it might not work. But we added the scrubbing gesture. So you can just scratch things out to remove them from the graph. So we really want to build an environment that feels natural to work with. Basically, creating software like you would draw a flowchart on paper, except without the weaknesses of paper, like it being a little difficult to modify things.
And the graphs be nested?
Yes. Yeah, that's a good one. So, I mean, each of these boxes that you see, they can be either code, basically a function, or they can be another graph. So you can always take a bunch of these boxes here and move them to a kind of subgraph. And these subgraphs, just like any of the other boxes here, can be reusable. So you can create kind of this more complex logic that way, while keeping the graph simple. And if you look at this screen, this is source code to Jekyll. Does anybody know Jekyll? It's a kind of website build tool that was built in Ruby, about 60,000 lines of Ruby code. This graph here is a re-implementation, a complete re-implementation, doing exactly the same as that 60,000 lines of Ruby code, but it's just this picture here. So you can really see things can be a lot clearer. You see, okay, that's how our data flows here, and you can go and replace things easily in this graph. But a lot of these boxes are actually like, this one is a subgraph, that one is a subgraph, and you can then zoom in and see what's going on there. And I mean, okay, maybe if I shut down the lights for a second, you can actually see something. This is always a problem with projectors. So this is another thing we haven't shown to anybody yet. This is the kind of design sketch for the UI. So you saw the graph editor and the minimap running, but one thing we really want to do is we want to expose version control. Basically you get a full record of every change done into your software, and you can easily step back in time. And the other one is collaboration, because really software is usually built not just by one person but by teams of people. So we really want to enable it that you can have multiple people working on the same graph at the same time, and you can see what other people are doing and all that. So if people modify the software, you know, if I'm editing the source code for this box, you would see a little picture of me there. You would say, okay, Henri is there, and so forth. So, lights back on, and we have a couple of minutes for questions.
somebody about this, they always point out the complexity issues and how it's never worked in the past, and why would it work now?
Mhm.
So what are the limitations you see that you have to overcome, and how are you planning on getting over those?
Iteration. I mean, we are getting more and more, we are eating a lot of our own dog food. The UI you see here is all built actually in NoFlo. So we are building NoFlo with itself now, and that experience kind of, you know, doing different things, like at the same time dealing with little visual things like this clock here, and dealing with more complex server-side things. We have payment processing done in NoFlo. We have build scripts done in NoFlo. People route SMS through NoFlo, and like trying to do all these different things, and then really listing the shortcomings and improving the UI. I mean, the concept of flow-based programming itself is robust. They've been running a bank in Canada for 40 years on a flow-based system based on Paul Morrison's concepts. So that part, I don't have any hesitations about. So really, I think the shortcomings are mostly in what kind of user experience we can provide here. Whether we can make things clear enough, whether we can make the manipulation of things easy enough. That's the main risk and the main cause of concern.
Yeah, I don't think you mentioned actually that this actually already works, but textually everything, and this Kickstarter project was for the UI actually.
Yes, exactly. NoFlo has been around for a couple of years. It's been used in production for a bunch of companies for that time. And the main thing we are building here is the kind of IDE for flow-based programming. Not just for NoFlo, but because we have this network protocol, you can also make this talk to the other flow-based programming environments. There's one for Java, there's one for C#, Go, Python. So eventually we hope that this user interface will be the de facto way of manipulating flow-based code wherever, whatever runtime, whatever target you have. Because even though I think JavaScript is awesome, I know it has its shortcomings, and there are good reasons to use other languages too. Yes?
Compared is flow-based programming to Unix pipes. What kind of semantics is on your connections? It's not synchronous by byte.
No, it's message-based. So this is basically a message passing system.
And how each unit reacts on the messages? Is it synchronous, asynchronous?
Asynchronous. But then the messages you send, like one obvious kind of problematic thing is synchronizing asynchronous flows back together, because you might want to, you know, flow back things back. And for that, the packets we send through these wires can have this kind of envelope information called grouping, which you can then use for arranging things. And the ports you have here are typed, so that's another thing that helps programming. So you know whether, like, this thing here expects to receive a HTML element or a number. I mean, JavaScript itself is loosely typed language, but and we are not actually enforcing that. If you want to set number to something that wants an object, you can do that. But the UI gently guides you towards not doing things that might not make sense. But there might be situations where you have a valid reason to do so. Anything else?
And you were showing the data flowing. Can you step through that?
No, currently there is no stepping, so it's really the real-time data flow here. But that's something we've been thinking about would be to, like, basically have a stoppable connection where you can say, oh, like, let each packet through at your control. And another thing that would be nice would be to be able to, like, eject failed packets there, just to see what happens. But there's still work to be done here.
And we were talking just about complexity. Can you actually show us the graph of what you're working on now?
The UI.
Yeah. How
Not,
complex is that?
not from this computer, because this is Ilka's. Unfortunately, the wonderful AV technology here didn't accept HDMI, so I'm not on my own computer. But yeah, I can definitely show you stuff later. What did I promise to show? Components, right? So one thing obviously is that because components don't know anything of their context, so they are very, very reusable. And people have been writing. The cool thing is, like, people can go and write a component and they can easily release that as open source, and then everybody else can use that. I mean, you can of course do your own in-house proprietary whatever components, but really in a lot of situations it makes sense to publish the stuff, because most of the things will be genuine. Like in the Jekyll example, where we built a full replacement of a 60,000 line code base visually, we had like 2 or 3 custom components that we wrote. So that's not too bad. Yeah. Yeah. These are reasonably simple. You register your ports, you react to packets coming through the ports, and then you send data. And that's it.
Are all the components in CoffeeScript?
Yeah, most components are done in CoffeeScript, but you can write them also in JavaScript if you want. You could write them in ClojureScript or TypeScript or Dart if you wanted to.
Whatever that compiles to JavaScript.
Exactly. Yeah. I mean, this applies to NoFlo. There are these other flow-based programming environments for other languages that have obviously their own ways to define components. But here's the Go environment. The developer of this one is also working with us to get our UI, the IDE, to talk to his Go environment. So if you need to do, let's say, very high performance servers, this might actually be a better option than NoFlo for the backend. And the good thing is, because flow-based programming is kind of standardized, you can actually connect things together. So for instance, there was a Nodecopter hackathon. Does everybody know the Parrot AR drone?
Yeah.
Like this flying quadrupter thingy that you can program.
Yeah.
We had an event where we built a flow-based system, or NoFlo system, where we had, on the client side, we had graphs that were showing like things like an altimeter for how high the drone is flying, and also listening to an Xbox controller and sending commands. And then we had a server-based NoFlo environment that actually converted those commands to things that the drone should do, and then talk to the drone. So essentially, we had 2 flow-based programming environments talking together and connecting the browser world, the web browser world, through a server with actually something physical that flies. That was pretty cool. But we are out of time, so I think it's.
Yes. Any other questions?
Yeah, I mean, I'm gonna be around, so
Yeah.
Feel free to.
Let's give a big
Wrap
hand
it
for
up.
the Henri, and thanks for coming. I think the only question here is that how worried we should be that will programmers be out of the work if you are keep going. So kill him in the evening, so we can.
No, I mean, we are going to see kind of the specialization there. There's
Right.
going to be people that build these graphs, and there's going to be people who build the components.
Right.
And I mean, that's what we are seeing in our own team. Like, it wasn't a decision that you're going to be the component guy.
Right.
People just kind of naturally drift to the area that they are most comfortable with.
Indeed. All right.